Hello, hello. This is 15 hours and 2 minutes. It's 3:02 in Berlin. Welcome to another live stream from OllyGarden. My name is Juraci. Kröhling. I'm a software engineer and I'm the CEO of OllyGarden. And in this session here today, we're going to talk a little bit about the OpenTelemetry agent skills that we launched last week. Thank you all for joining me today. And as a guest or a co-host for today, I have Nico. I'm going to call Nico in a moment, and Nico is going to introduce himself. There you go. Hi, Nico.
Hello, everyone. Hi, Chuka. Hello, everyone. I'm happy to be here back in the live stream. For those who don't know me yet, I'm Nicolas, and I'm working at OllyGarden on everything AI-related, which means right now I'm spending most of the time on working on our AI agent Rose, which is optimized for OpenTelemetry. And today I'm very excited to share some insights about OpenTelemetry and AI agents.
Very cool, very cool. Yes, so if you've been following us on LinkedIn or social media, you probably know by now that we have a new set of skills that we launched last week. If you've been following what we've been doing for a longer time, then you probably remember that Nico and Pavel from Red Hat, they shared during KubeCon in Amsterdam, Let Me Be Your OTel Champ. I think that was the name of the session there. And the idea was, well, Nico, what did you show there? Tell us.
Yes, so basically we ran different kind of experiments where we used AI coding agents for OpenTelemetry related tasks. And the interesting thing, which we found again and again, is that the agent itself is intelligent and the agent itself is incredibly powerful, but oftentimes it struggles with finding the relevant information or recent information. So, for example, one issue which we ran into quite frequently was that it simply used old versions from old SDKs instead of the most recent one, probably because it was somewhere in the old training data set, which was used in the model, in the background, in the agent. So we presented different kind of approaches there with skills and also with an MCP server, how you can improve that behavior, because oftentimes it's not that the agent isn't smart enough, it's just that there's so much information about there in OTel, but also general out there, that it's having struggles finding what it actually needs.
Yeah, exactly. So, and what are the skills that we launched last week?
Yeah, so last week we launched a set of public available OpenTelemetry agent skills. I'm not sure, I think we have a link somewhere in the post as well. And the idea of those agent skills are exactly what I just mentioned. So the OTel ecosystem is quite broad. Changes are happening like every week. There is, or at least every 2 weeks for the collector alone, there is a new release, and for the SDKs and everything, there are a lot of changes every day. And just navigating around the documentation alone is already a big thing in the big OTel ecosystem. And the skills which we present there are non-opinionated by design, so they don't represent any opinions on how you should use OTel, and instead they aim to guide your agents how they can effectively navigate the OTel ecosystem. So for example, we have something called the OTel SDK version skill in there, and in there we have an automatically updated index, a markdown file with an index lookup table, and there we reference the latest available versions of every SDK. And by that, we noticed that the agent increases the capabilities in finding the most recent versions of the different SDKs quite a lot, while consuming a lot less tokens. And this is just an example of a lot of different ones. So I think, Juraci, you spent a lot of time on adding something for the collector, which, as far as I saw, will help a lot as well to navigate the collector with all the different components. And yeah, for a lot of different components or SDKs in the OTel ecosystem, we have something available in there. And I think it's growing. So we are at 14 skills now, but probably soon we might have a lot more.
Yeah. I think we might even have a little bit more already, but I think we started with 14. So perhaps we do have, I do have a few ideas for new skills, but let me share my screen because I wanted to show a few other things as well. So when I look at here, I look at other screen, which is close to me. Let me see, where do I turn them on? There you go, cool. All right, so I really wanted to give you a very short overview of what we do and why we are doing those skills and how do they fit into the main picture, into our main strategy. So the idea that we have for OllyGarden, so just recap for the people who are new here, we care about the quality of the instrumentation, quality of telemetry as a whole for your systems. We believe that a lot of the telemetry pipelines out there, they are inefficient, they are insecure, inefficient, they are the telemetry that is flowing through the pipes, they are of bad quality. And there is no better way to fix bad telemetry than to fix the telemetry, the instrumentation, right? So the instrumentation generates telemetry. So we think the best way of fixing bad telemetry is by fixing bad instrumentation. And let me see if I can change it. Okay, there we go. And one of the things that we, yeah, it's a little bit slow here. So one of the realizations that we had, working on the new code for the garden last year, is that towards the end of the year, most of the code that we are producing is by agents. At the beginning of the year, I was still doing code on my own, like with my own hands. But nowadays, it's not with that. It's not like that anymore. And most of our code at OllyGarden is written by agents. Of course, there's a lot of engineering still going on in there, like in thinking about the solution and directing the agents to doing the right things. But we know that most of the code now is done by agents, and they reproduce the instrumentation patterns that they've been trained on, right? So they were trained on bad practices, and they are reproducing those bad practices. And in this new world where agents write most of the code and they write it 10 times more than humans could ever write before, then the patterns that we used to do or the approaches that we used to apply or employ, like eBPF instrumentation, they don't work anymore. They just, it's just too much telemetry. It is high volume and low quality. Now, the fix for that in our vision is we can use the same tools that we are using for the code generation to also generate telemetry. We just need a good guardrail. We just need good instructions and good agents to do that. And this is what we've been producing. So we have, on one hand, we have an AI telemetry analyzer where we can analyze, we can understand what is wrong, what is bad telemetry on your telemetry. So we receive the telemetry that you send to your Grafana, your Datadog, your Dash0. We receive the same telemetry, and then we can tell you what is wrong. Now, what we also have is Rose is an AI instrumentation agent. So that is the part that fixes the bad instrumentation, so that bad telemetry becomes less frequent. This is the mental model. This is how I visualize our solution. So you have a service being observed. This is your business. Those are the things that you run. This is the whole purpose for your software. Like your software is there being observed, and the telemetry from them, they typically go to an OpenTelemetry collector that you have internally, and from that collector, it goes to your backends, like Grafana, Datadog, Dash0. And then at the same time, you can send us that telemetry, we analyze it, and that serves as information, as a source of information. One of the sources of information for Rose. Rose can see, okay, so I see that the service X has PII. And I know how to fix PII leakages, right? So, and then we fix the bad instrumentation at the source. Instead of you having to use a collector in the middle or using a pipeline product that you have to configure, that you have to fix the problems after it's created, we do something different. We go to the origin of the problem and we fix it there, so that the bad telemetry is not even generated in the first place. This is the whole idea. We're going to get to Rose, so bear with me. But to show you what is the big picture here, again, this is our Insights UI. So this is what you get when you go to OllyGarden.app, when you sign up for OllyGarden, and you have some non-deterministic and deterministic processing of your telemetry, and we show you information that is valuable to understand what is happening with your telemetry. One of the things that we do, for instance, is we do a breakdown of your signals. So how many traces you have, how many spans or how many logs, how many gauges, sums, and histograms. So you can have an idea of the volume or where your cost is located. We also show you how much you can save if you employ some of the techniques that we know to be commonplace, like deduplication of logs and perhaps removing some of the metrics that we think it should not be having in the first place. We also show you SLK distribution and what are the critical findings and health metrics. And one of the things that I didn't know when we started OllyGarden was how much PII we would find on telemetry. Right, so this is one of the things that we actually didn't know. We were finding so many, but that kind of became one subspecialization of our insight service. So we can find PII where most services, where most systems cannot find PII. Now, and then we get to Rose, right? So Rose, within the platform, within OllyGarden.app, you can go to instrumentation tab, and you have some information there. But I'm going to pass the word to Nico to explain a little bit about Rose to you all. There you go, Nico. You are back online. Yeah.
Yeah. Thank you. Yeah. So I'm very excited to speak a little bit about Rose, the OTel expert for every team. And like Juraci already alluded to, is when we think about OpenTelemetry instrumentation, there are a lot of different ways you can instrument your code base. And on the other side, there are also a lot of things your code base and the instrumentation, which is already present today in your code base, can tell you about the instrumentation of it. So just by looking at the code, you will be able to learn a lot of the things how your application is instrumented. The challenge for us humans is when we look at a code base as its whole, it's very hard for us to narrow down small, subtle bugs or issues, or maybe things which we simply don't know in our instrumentation. And that's exactly where Rose comes into play. So Rose is plugged into your GitHub repositories and then is having a look at your code base as a whole. And from there, it's launching different specialized review agents in order to detect different kind of instrumentation issues or possible improvements. So those findings, which we will find from there, you can see here, earlier here, but also here as well, we categorize them into different severities. And based on that, we will tell you, okay, here in your application, you're currently logging, for example, in the right, owner and pet personal data to your log output, which is something you probably don't want to do. And those are the kind of things which you know they are bad, you know you don't want to do that, but being sure or quite sure that you're not doing that is hard, because you need to have a look at your whole code base. And especially as everybody of us is generating more code and code and code, and many people even skip reading some parts of the code, it's becoming hard to have the trust and that confidence in your instrumentation that you are really doing or not doing those kind of things. In that case here, PII leakage is one example, but really the findings which Rose is able to find is a very broad range. And it depends, like I said, on severity. So sometimes it's quite critical, like we can see here. But Rose also helps with being more compliant to the OTel specification, for example, to the semantic conventions. So the semantic conventions are evolving and changing quite frequently. And when you want to keep up with them, you have multiple options. Either you track the changes you're in the topic and then you apply it, or you let Rose help you with that. And we will come back to the topic later, how Rose is doing that under the hood. So how Rose uses these skills under the hood to help with that. But after we then detected those issues, Rose is also able to help you with fixing them. So along with the OllyGarden UI, you will get an OpenTelemetry instrumentation dashboard, like you can see here on the screen in the left, next to your source code. Similar, like you can update your dependencies, you can see your OpenTelemetry instrumentation. And then you have the option to, first of all, see what we identified there in the repo and to click the checkboxes from there or via the OllyGarden UI to fix the improvements or possible issues we detected. In that case here again, we have the PII leakage. So we activated the checkbox. That's something we definitely want to avoid. And then a couple of minutes later, we get a PR where Rose fixed or redacted that information in our code base. And then a human should review those changes and can merge it in the end to main or to your branch. And that's really the idea of it. On one side, to find and to detect those issues, and then at the same time to have the convenience to fix them within just a few clicks without having to check out a new branch, raising a new PR, for those kind of smaller issues. And yeah, that's Rose at a first glance, how it works from a high-level perspective. And now we'll go into a bit more detail. I think Juraci will take over here, right?
Yes, exactly. So yeah, what I wanted to show you all is the full picture here, and this is how the full solution works, and how the OpenTelemetry agent skills they are part of this vision. So we do see we need a better on-brand name for the brain, but we have this brain that really has all of the context, all of the information that is required to help you on your OpenTelemetry journey and helping you in fixing the bad telemetry, finding and fixing bad telemetry and instrumentation. So the idea is we rely on the base LLMs, and it should not matter which LLM that is. So if it is a new model from Anthropic, or if it's a new open weight model coming from China, I don't know. So the idea is the models, they are very good at coding. They know Go, they know Java, they know TypeScript. We can rely on them, and we can build on top of those. Now, the thing that they don't know is the things that just got launched like last week. For instance, the Go compiler time instrumentation library, or the project was released V1 just last week. So how can the LLMs know about that? How can they help you use that? They just cannot. So what we do is we build an OpenTelemetry agent skill. So that's the repository, open source, free, unopinionated or non-opinionated that Nico mentioned. And that serves as a layer upon the basic LLM. So the base LLM has the knowledge about the Go, Java, TypeScript. And on top of that, we add a layer of OpenTelemetry facts. So we update the knowledge of the LLM when it comes to OpenTelemetry. And we include things that are new in the community, things that got updated, new versions of the collector, new components, or things that we know from OpenTelemetry, and we add as facts. Again, no opinions. Now, what we are working on already, and what is also part of the base for Rose, are the OllyGarden opinions. And I'm not going to invest much time here on talking about the opinions, but this is why we can tell that the OpenTelemetry agent skills, they are non-opinionated. So those are the facts. We look at the source code, we look at documentation, and those are the things that are true to the project. And then we have our own opinions, and some of you know our opinions about a few things, and we encode those opinions in the OllyGarden public opinions. Now, we also have a proprietary knowledge base, proprietary skills, so that we, based on telemetry that we've seen, based on advice that we've given to other companies, we encode them as part of the proprietary knowledge. For instance, how does vendor X charge? How does vendor Y charge? And on top of that, or in addition to that, we have a customer context. This is a company context, meaning we see information from a specific company, and then on that bucket, on that context file, on that context directory, we know they are customers of this vendor. They pay most of their money for observation backends for metrics, or they care about X, Y, and Z. And we encode all of that. And when we mix them all together, we can generate the insights that are highly targeted to that specific company, focused on the problems that they have right now. So that's why the telemetry analyzer is so interesting to companies out there. We can tell them what really matters to them. It is focused on their use case. So this is all to show you that we have a vested interest in making the OpenTelemetry public facts useful and used by everyone and anyone. It is part of our strategy. It is part of our business. That's why we are going to keep maintaining them, keep them fresh, because they are part of Rose. And Rose is a product that is built on top of those opinions, the proprietary knowledge, and the facts, and consumes the customer context as well. So this is the whole vision. This is the whole view, and this is why you can trust, you can depend on our skills on your daily basis. And trust that they're going to be open source, they're going to be updated, they're going to be available and high quality for you. So this is it. I'm going to stop sharing my screen for a moment, and I think Nico has a demo for us.
Right. So I will.
Which screen should I share here, Nico?
My browser. I would first give an overview about the OTel agent skills in the browser in GitHub.
Is this the one?
Right. Yes, there we go. So here you can see the repo, which we mentioned, which we already shared, where you can find the skills and with some installation introductions, how you can set them up in your repository. But I would like to pick out a few examples here to give you an idea about what we mean with non-opinionated and how we still help the agents to guide them better when it comes to OTel. So you can see the different skills which are present as of today. And I would like to pick the OTel semantic convention skill and also the OTel declarative configuration skill. So if we first take a look at the OTel semantic conventions, we can open that skill here. And the first thing you will notice is that it's quite short, and that's by intention. So we usually try to avoid putting a lot of plain text information in the skill itself. And rather, one thing we like to do is we like to provide upstream resources in which direction we can guide the agent to. Because with that, we will get two advantages. On one side, the documentation or the official project guidance will be the source of truth. But at the same time, we make it easier for the agent to find the relevant information which should be up to date. And in that case here, we can see we define how the agent should query or retrieve semantic conventions. So, and semantic conventions is also an interesting case, because when we think about the semantic conventions, it's quite a large registry of different things, how you should name your attributes, how you should name your span names, and so on. And agents love that. Agents love to see that markdown file, which you can retrieve from the OTel documentation to see all the different attributes. But the challenge which comes with that is, if you want to navigate through the semantic conventions, because there are so many, it's hard for the agent to skim or to read all of them. And that is exactly where this skill comes into play and helps you with. So we define a workflow here, how the agent can use the OpenTelemetry semantic convention skill. And then we have a small bash script here, which is essentially a wrapper around the upstream semantic conventions, and it just provides a few example commands how you can invoke the script. And then we return a more agent-friendly format of the semantic conventions registry. So in that case here, for example, your agent could run the query OTel semantic convention script, and the agent would provide the HTTP keyword, and then he would get everything which is relevant for the HTTP semantic conventions. And that's like the whole idea about that, to guide the agents how to get the relevant information more efficiently. We're doing something similar for another skill I already mentioned, the OTel declarative configuration. So I personally, I'm a huge fan of the OTel declarative configuration. I use it in all of my projects. But this is not about explaining why you should use that or if you should use that. This is more about making your agents familiar with that whole concept. Because if you ask your agent today how you would set up OTel in your project, it's most likely going to recommend you the typical way where you set up the SDK in your code base and define environment variables, and not the declarative configuration, which is quite new, simply because most of the code out there is defining it inline in your code base with the traditional way how you would set it up. And the declarative configuration is quite new. In some languages, still experimental, and therefore not as popular as the traditional way to set up OpenTelemetry. However, what we are doing here is we are providing, again, the source of truth where the agent can learn more about the topic here, the declarative configuration. And based on our observations and evaluations, it increases the quality or the efficiency of the agent quite a lot. So in my next screen, I'm going to share VS Code where I executed two very simple examples. Like we can see here, let me head over to VS Code, yes. So in the first example here, I asked the agent how I can set up the declarative configuration for Go and how I would configure the deployment environment name in there. And then on the left, you can see without skills here. And on the right, you can see what happened with skills. And we don't need to go through each and every single message in here. But one interesting thing here is for the approach without the skills, the agent decided to launch a sub-agent, which took almost more than 1.5 minutes, did several tool calls, consumed like 140,000 tokens, and then came back to the main agent, to the parent agent, to give us a response. And yeah, it took quite some while and consumed a good amount of tokens. When we're doing the same with these skills, what I mentioned, where we define the source of truth, I mentioned earlier, it directly had the relevant information available here and started using or fetching that information. And then it didn't need to launch a sub-agent, just fetched the relevant information and went from there to give us the same answer. So those agents right now, they are so good when it comes to using their tools like web fetch or web search. Usually they are able to retrieve information, not if they are completely new, but if they are quite new or quite fresh. But the challenge is at which cost. So on one side, it will consume quite some time until the agent finds it. And on the other side, which is the more critical thing, it will consume quite a lot of tokens. And we as engineers, we should always try to keep our context window as efficient or as small as possible, just focused on the things we want to do. And when we now think that we have our agent with the system prompt, with all the tools which are present, perhaps with a few MCP servers configured, and some other skills which already live in the context window. In addition to that, the whole code-based context the agent is in right now. And then on top of all of that, the agent still needs to query the OTel documentation. Quite a lot of things go into the context window. And therefore, those skills are really a big help when it comes to improving how well your agent performs in terms of OpenTelemetry. I have another even simpler example here in the different tab. And what I asked here was simply, which OTel semantic convention should I use for my HTTP server application? So very, very basic questions, very, very simple. And again, in both examples, the agent found almost the same or the same information. But the interesting thing is, even for that simple question on the left side, it took us 35,000 tokens. Whereas on the right side, I think we can see it because my face cam is in the way. But yeah, it used 11,000 tokens. So you just need to trust me. It used 11,000 tokens. So without the skills, it cost 3 times more tokens to get to the same information. And like I already mentioned, when we now think about our whole code base at a scale, when we want our agents to perform with OTel, that's quite a big difference, or it will make quite a big difference in terms of the efficiency and the quality at some point based on what the agent is retrieving. One last example I would like to show is when I head back to my browser, when I pull up an actual example of Rose. So right, there we are. So here I'm in our OllyGarden UI, and as Juraci already mentioned, when you head over to the instrumentation tab, you will find the whole Rose feature or the Rose product, and then you can head to your repos. And I have a real repository here, microservice of us, where even internally we have different kind of insights or findings we detected. And one thing which I would like to pick here is the following one. So here it's saying that our messaging operation type uses non-standard values other from what the semantic conventions are recommending. So what the agent, or what Rose in that case found here for us, is that when we look at the semantic conventions documentation, we are using not the official operation types which are defined in there. It's not a critical issue, but it's worth mentioning when you try to do it the right way. And to detect this kind of finding, Rose under the hood has used the semantic convention skill I just showed to you. So that's how it all comes together in the background, that Rose is using the skills we maintain and we share in the repo under the hood as well to navigate the OTel ecosystem more efficiently. And yeah, there are a lot of more things we use those agents for the different languages, for the declarative configuration, for the collector itself. But these were just a few examples how it will help you. And yeah, it's super interesting. Yeah.
Yeah, that's wonderful. And one thing that I like, Nico, is that you also use the text editor, like the open code is already in the full screen on your editor, as if you don't edit code anymore. Right? I think it is a common pattern that I'm seeing as well. Cool, very cool. I wanted to give you all a couple of other examples as well. So Nico showed you how to use the skills for the main intended purpose, which is go there and find and fix a few things. But I wanted to show you a couple of other things as well. First one is, how can you use those skills to use something that no LLMs know right now? If you just open code or code or codex, you just cannot do what I'm going to show you right now, which is, let me share my screen now. there, but not this. So you can do this, but you cannot do this. All right, so if you open your Claude code, you cannot just say add some OTel compile time instrumentation to this application. Like, it is not going to work for Go. This is a Go repository. This is Go Gene Railroad. So this is an example application. And I've just done that. So that's my prompt. That's me vibe instrumenting my application. No engineering practice is required. No, it's just vibing, right? So and then it loaded the Go skill. The compile time instrumentation keyword is probably sufficient to trigger this one here. And then it read how it works, and it started doing some work. I did it just before our live stream here. And once it was done, so it took 2 and almost 3 minutes, so perhaps a little bit less than 3 minutes. And it said like what's going on. So now OTel C requires Go 125, so it updated all of our Go mod and so on. And a few things that it did as well was, where is it? So it updated the README file, but it also did the compilation of our application using the way that OTel C asks applications or recommends. So it knows how to compile those applications, and it knows that it builds a map here on this JSON file. So it confirmed that it did what we wanted to do. Again, it is using the power of LLMs. LLMs know Go, so they can understand the code. They probably they can see what are the endpoints and can match what is the expectation from this tool that we taught the LLM how to use it. Right? So it matched those two things, and then it said, okay, so it emitted this one here plus those other database spans. Now let's take a look at the result there and see. So and then what I've done after that was, let's now have a container with Grafana LGTM to visualize the telemetry. So, and then it did. It started a new Docker Compose. I don't particularly like Docker Compose here for this repository. I think it went a little bit too much for my taste, but it's okay. At least for the demo here, I think it's fine. And then it did. It is running. It is there. LGTM stack is running, receiving, and so on. So what we can do here now is I can show you how one of those spans they look like. Right. So we can see here. This is 8 minutes before our live stream started. And so perhaps I should increase my font here a little bit. And then you can see this is OTel C instrumentation for net HTTP, just proving you that this really happened through the OTel C layer. It took 7 milliseconds for that one. This is probably a code request, a code start, my host name, my OS description, and so on and so forth. Everything is in there, including some span attributes. Cool, very nice. So this is one of the things in there, but I don't particularly like this, the way that it's done here. Why? Because it is a disconnected trace. I see only one span in here. And I just know that there were some database calls made there. If we go in here, I can see, let me see if I can, oh, no, that's the wrong shortcut. Let me refresh my screen. There you go. So perhaps I should remove this one. Yeah, that's bad. Okay, cool. Anyway, so what I want to show you is we should have here some database spans. I know they're there. I could see when I go, perhaps I can just...
Maybe you need to increase the time window.
Oh, there you go. Yes. Yeah, that's true. So for the last 3 hours, let's see. No, I think I'm missing some. What am I missing? What is going on? Anyway, so we can see the spans in here. Right, so we can see the disconnected spans. We can see them here. So what I want to do now is I want to connect those. I want to see those as part of the same trace. So what I've done, let me see if I can go back here just to the screen. Yes, there you go. And what I'm doing here now is in my Claude code, I go back there, and this is where my engineering knowledge comes into play, right? So now we stop the vibe part, and we now wear the engineering hat, and I know how it should look like. I know there should be a request and a database span on the same trace. So what I do then is I tell it, fix the context propagation, so that HTTP requests and database spans are connected. I should probably I probably don't need to use the word context propagation here. I could probably just say, make the HTTP request and the database spans connected. And it would probably have worked. But my mind, my head, I know what the problem is. I can try to understand. I can try to visualize the problem, and it is probably like that. And the model is saying, so Fable here is telling me the root cause is likely that the app server and the app never passes the context into GORM, and so on and so forth. And then it just did, right? So it confirmed the problem, and then it fixed the problem for me. I don't even know what is going on in here. I think it finished after we started the live stream. So I didn't read this one here, but what I did do was, while Nico was saying, was just verifying that we do have one. Well, let me hide my screen. So hide the camera and keep audio, and this one here the same. And then you can see here a full trace with the get and then the spans in here. Right, so we can see the context propagation working here as well. Again, I don't have to know anything about OTel or Go time, the compile time instrumentation for Go. I don't have to know how it works. I can rely on the skills for that. I can just prompt, I can add the thing there by using the skills. So this is one thing that I wanted to show you all. The other thing that I wanted to show you all is, let me return here my camera, show camera again. The other thing that I wanted to show you all is this other example here. So one thing that I'm doing with the skills is I'm validating configs. I'm validating information that I'm providing to you all as part of blog posts. Right. So we have a blog post called Decompose OTel Configs. You probably remember about this one. It's from a few weeks ago. And what I've done when I was preparing that blog post is, after it was written, after I verified the words, after everything was fine, I said, verify that all snippets are valid. Now, I've done it back then. This example here is from now. So what it showed me just before our live stream here is some of the things, like the collector moves so fast that a few things that were true back then, they are not true anymore. So probably we're going to update this blog post. But I can just tell the skills, I can just tell Cloud Code, like, look at this blog post and verify that all snippets are valid. Though that was last year, a couple of years ago, when I would be writing blog posts, I would have to run them myself. I don't know how much time of my life I invested in verifying all of these steps for one of other blog posts that I have, which is how to protect OpenTelemetry collectors. Right. So there is a blog post on Medium, it's still where I show you how to place a key cloak in front of your collector. How many times have I run the same steps over and over just to ensure that the blog post was still accurate years after it was first published? Now it's easy. I can just go in my Cloud Code and say, verify that all snippets are valid. And it does it for me. So it actually loaded a few skills on the opinions part, so not on the facts. But we do have a skill on the OpenTelemetry on the OpenTelemetry skills, agent skills that we published. We also have a validate config, and the validate config is the one that is also used by this one, and it verifies, it runs the collector, verifying that both, if I have a OTel statement, for instance, or if I have a processor, a transform processor, the validate collector config is going to send some telemetry through telemetry gen, verify that all the transformations are in place, and export the telemetry to a JSON file. And it's going to verify that all the transformations, they were done, they are visible at the resulting JSON file. So that's how we can validate the config. This is showing how to do other things, so not necessarily instrumenting our code or configuring our collectors, but also in helping us write blog posts or verify snippets that we are sending to our customers or sending to our users, and helping people achieve their goals there. And with that, let me go back to our live stream. There you go. So let me stop sharing my screen and going back in here. Is that the one? Oh, Nico, let me show you here as well. Cool. All right. And I think this is it for today. So this is what we wanted to show you during this live stream. We hope that we were able to both show you something new when it comes to OpenTelemetry agent skills, but also gave you some ideas on how to use it. I'm really curious to hear from you what are the cool things that you are doing with those skills. But the second thing that I really wanted to pass to you as well, to show you all, is how important those skills are for us. They are not there just for marketing purposes. We are not publishing them to get some attention from you. We are publishing them because they are critical for our strategy, for our main strategy, which is Rose. Rose is part of the fixed bed telemetry or fixed bed instrumentation part of the story, and it is part of our vision. And the vision that we have is every company out there, they should be able to confidently say that they are collecting, transmitting, and storing the telemetry they need without excess. And the telemetry they need doesn't contain PII. The telemetry they need is not duplicate, it's not repetitive, it is costly efficient, it is low volume and high value, which is the opposite of what most companies have nowadays, which is high volume and low value. So we want the opposite of that. Nico, any final words?
Yeah, I just wanted to conclude that I think we are in very interesting times. Those skills give a first glimpse in what's possible today and what probably will be possible in the future. And yeah, I'm very excited about more things we will announce and speak about in the future, because some very interesting things are coming there. And yeah, super excited.
And I guess the invitation here is if you think that you need some help there, if you need a little bit more than just those skills, get in touch. We are cooking some things for the future, and we would be really, really glad to show you a little bit of what we are doing and onboard you as a partner for the next steps of OllyGarden.
And one thing I think, sorry to jump in, I think one thing we forgot to mention is if you have a skill or if you have an idea for a change to a skill, we are open to contribution. So we would love to see if anybody of who's watching right now or the recording, if there's a skill which is not there right now, if you create an issue or even create a skill on your own as a proposal, that would be super cool to drive that forward.
Exactly. And if you find anything that is not working, let us know as well. Open an issue or even better, open a pull request. Cool. That's it for today, folks. We went a little bit over what I was planning to say or the time that we were trying, but I think I hope that you enjoyed. I hope that you took something from the session today. Even if you don't want or if you cannot use the Rose for some reason, do use these skills. These skills, they are already very helpful. They are helping people already today in achieving things faster than they could before. Thank you very much for your attention, and